Hi, welcome to aarna.ml GPU Cloud Management Software 5.2 demo. But before we go through the demo, very brief about our product. So our product essentially manages both centralized AI factory and distributed AI grids. And our software is composed of two layers. The lower layer is all dealing with the infra, which offers multi-tenancy with full isolation. And the top layer supports PaaS features like instance creation, job submission, model serving, etc. Seven elements of hard isolation. This is one of our unique differentiators. So we support hard isolation across compute, CPU, GPU, external gateway, NVLink partitions, Ethernet networking comprising VXLAN, VRF, isolations, InfiniBand, PKey, and external storage through VRFs and vendor APIs. So we will see in the demo how we implement this for tenant specific scenarios. So this is the demo topology. So this represents a real world deployment. So we have multiple scalable units which are comprising of GPU compute nodes, and these various compute nodes which are organized in scalable units and along with external storage, these are connected with multi-tier switching of leaf spine and core switches, and then we have out of band switch, and our software itself sits in a management network and is connected to all the compute nodes and switching elements through an out of band network. So this is the demo storyline that we are going to see. So once the infra is racked and stacked, then our software comes in. So we start with complete automated discovery of the topology that we just saw. And once the topology is discovered, the admin persona can update the catalog. We create underlay network configurations. You can see some various observability and monitoring aspects of our product. And then finally, we onboard the tenant who shall use this infra. So this provides real zero touch automation and OpEx reduction benefits for the customers. And then once this step is done, then the tenant personas kick in, and they start consuming this infrastructure. So they start isolating their resources. So we'll see how VPCs and subnets are created by the tenants, how they allocate bare metal for themselves, the external storage and virtual machine as a service. And under the hood, that's all achieved through the hard isolation that I just talked about. And finally, the tenant user persona. So now that the whole infrastructure is set up in a secure way, how to monetize it through various use cases. So we'll see two use cases where end user can um, use our PaaS features and speed up their AI ML development for various use cases. And finally, once you have some models ready, how you can monetize it through a model inferencing as a service. So that's the last part. So let's log in as a P admin, and we'll start with the overall infra discovery flow. And in this infra discovery flow, what we are going to give is all the details of the high level MAC addresses of the core switches. We'll be giving the details of the gateway and the border leaf switches, etc. And then all the topology discovery takes place in a completely automated way using the LLDP protocol. So we are all giving the inputs that are required. We are now adding the details of the external gateway, border leaf and external IP details, so that we are able to link that to a topology, and that helps us while creating the external gateway multi-tenancy. And here we have integrated with F5 as an external gateway. So the tenants can also ask for the public IP addresses for a few of the bare metals that they wish to be reachable from the internet, and that is what we have specified. We have reviewing this, and then once we have reviewed, we start the infra discovery. And once the infra is discovered, this is how you view. It is a connected topology consisting of all core, spine, leaf switches. You see all the connection details between the switches and the other components. You see all the management, compute and storage nodes, all the switches. You can click to any of the node and then you can see how those nodes are connected to each other. Then we move on to now onboarding the telemetry, which is NetQ, and this is used for the switch telemetry monitoring. Now, once we have discovered the topology, onboard the telemetry, we are now doing the topology validation, because what we have discovered needs to be in line with what has been designed. And if in case there is some discrepancy, the software is able to show that. But here it's all success. So we are doubly sure that the topology discovered is as per the design. And then we trigger the underlay configurations. As part of underlay configurations based on the NVIDIA reference architecture, all the IP assignments, the BGP settings and all everything take place. So now we have the discovered infra that is able to talk to each other. We are subscribing to few NetQ events so that we can monitor. And now we are setting the catalog pricing, because this is what will be available to the tenant user for actually subscribing. So NCP admin is setting up the price and he will save it. We have integrated with a billing module called Monetize 360, and this is all transparent to the end user. So here we are creating the tenant which will get added into the billing system. We are specifying the billing parameters like the currency, the frequency of billing, etc. That will all get configured in the billing system. And under the tenant, we are creating a tenant user. Now the user to whom we had asked for registration, he has received the email and is signing up using that email. So this is the sign up procedure for the end tenant. So he has signed up and he will start with creating the VPCs. So this is typically a tenant admin who is creating the VPCs, say for compute fabric, is creating the subnet for that. We can create multiple VPCs and multiple subnet. So here in this example, we are also creating for a converged network, which will be useful for communicating with the external storage. So we have created two VPCs here and two subnets. We'll also specify the security group. So in this particular demo, we have integrated with F5 for creating all of these firewall related configurations for tenant. And then once these are all created, we are moving ahead with the bare metal allocation flow as a first step. So here we are selecting the bare metal, we are selecting the VPCs that we just created. And then you can see that the bare metals are being provisioned. You can see 3 servers, those are getting provisioned. Now we are moving to the external storage allocation, because you also need to have an external storage through which your training data can be accessed. So this is all in a seamless way. We just specify the size and you can see that that's all has been provisioned. So now you have the metal allocated, the storage allocated, you have the VPCs in place, and you are now seeing the compute node observability. You can see from a single pane of glass observability matrix. Now let's move on. We will start with the VM allocation now that you have seen the bare metal. So this is also a very simple step. You just go and say that we need a VM. You give the name to the instance, you select the flavor, you specify the SSH key so that you can access it, and then just say allocate. And so you can see that the VM provisioning is taking place with the options that you have selected. Now that you have seen the IaaS features, let's also see some PaaS features. So we are logging as a tenant admin, and this tenant admin will create a Kubernetes cluster and then make this Kubernetes cluster available for the end users who might be a MLOps engineers development team to get started with their deployment. So here right now we are starting with importing of the bare metals. So previously you saw that we discovered the topology, but in case if there is an existing topology, we can also import those. That's what you are seeing here. So importing 2 servers. You've seen that import is fine. There are no clusters. So let's start with Kubernetes cluster creation. Again, this is a very simple step. You just give the name to the cluster, select the Kubernetes versions. There are few templates also available. You can choose to select any of those templates, or you can also go with none of them. And you select the worker nodes that needs to be part of this Kubernetes cluster, and then click provisioning. So here in the backdrop, Kubernetes cluster provisioning is taking place. You can see that the GPU count, the nodes that have been allocated. And now also let's add the end user persona who is going to use this Kubernetes cluster. So we are creating a end user, and this end user in this case is a AI ML ops developer, so they can access the cluster that was created by their admin. So the tenant admin role has finished. We are logging in as an end user, an MLOps engineer. So you can see the cluster that was created by that admin that's running. So this is the catalog of applications that is available for the end user. Now this user is interested in ML flow. So just with few clicks, he just selects the application, gives some name, the namespace, etc., and get that deployed on the Kubernetes cluster. So the application has been deployed successfully. Let's check whether the application is deployed. So there is a terminal that is available to be accessed from the UI. So we'll fire some Kubernetes commands to ensure that the ML flow is running. So that's what you see. And this is the ML flow dashboard. So, the developers are all set for their work in a very simplified way that has been enabled by this platform. So now let's move to the last use case, which is model inference as a service. So assuming that all of this AI development has happened, and a provider wants to host one of the inferencing service for monetizing. So this is the provider login. These are the models which are production ready, which can be deployed for model inferencing as a service. This is the infrastructure, the cluster which is there. So this process starts with creating the endpoint that will be accessed by the consumer of this service. So the provider starts with creating the endpoint, giving the endpoint name, the host from which the endpoint can be accessed, any TLS configurations, certificates. We created the endpoint. Now we will select one of the models to be deployed. Now this is a model from Hugging Face. So we are giving the Hugging Face token so that we can deploy from the Hugging Face repository. It could be any other repository, private repository as well, or NVIDIA NIM for that matter. We give the GPU types. There are a few auto scaling parameters here, when to scale in and scale out. What should be those replicas, whether it should scale from based on pending request. So those all parameters could be specified here. And then finally the rate limits and the pricing. So once all of these are specified, we start with deploying of that model. That model gets deployed on the Kubernetes cluster that was created. We'll again verify from the CLI, which is available through UI, to see that the model that was deployed, what's the status of it, and it's running. So you can see that model deployment is success. Now let's invite an end consumer who is actually going to hit this endpoint and consume this service. So we are creating that end tenant end user persona. So we have created that. Now let's log in through that end consumer who shall be accessing this model inferencing as a service. So when this persona logs in, they will see the models which are available and the rate, the pricing that you just saw. Then we add the API key so that that API key can be used by the end user either in their applications or UI. So we created that uh, API key, and uh, the API key is only visible once, so you need to copy that. And we also have a playground on the UI where you can put some sample queries and get a response for initial testing. And you will also see that the tokens, if you go to billing, the input and output tokens have been updated based on the query that has been given. This is a small chatbot application that we have developed just to demonstrate how easy it is. So the API key that we created, that will be used in the client code here, and this is a typical chatbot application by customer care. And you can see that this model inferencing service returns the response based on the query, right? And again you can see the tokens are uh, increased. That's the billing. So that is what we had in the demo. Thank you for watching.